Very good morning to my dear class 9ers. Hope all of you are fine and safe. So today we are back again with the continuation of our online classes. So today we will start with a new topic, with a new chapter, thermal expansion. So thermal expansion means, the word thermal expansion means expansion of a substance on heating. When a body is heated, they expand, and that expansion we call it as a thermal expansion. And expansion takes place in all the three different states of matter: solid, liquid and gases. In solid, they will expand in length, they will expand in volume, they will expand in area. And liquid and gases, they do not have a definite shape or a definite size, okay? So they will expand only in volume. Okay, so this way the expansion takes place in the three different states of matter. So before we come to thermal expansion, let us start with the heat and temperature. Now heat. Now what is heat? This is a very common word, okay? Heat and temperature. The word heat and temperature is a very common word in physics. So now heat is a form of energy which flows from one body to another due to difference in temperatures. That means the heat is regarded or considered as a form of energy. Okay, now why the heat is regarded as a form of energy? So before we come to that point, let us discuss about the term energy. Energy is the capacity or the ability to do a work or to perform a work. Okay, if you have got energy, then we can able to perform a work. Let us take our own example. Okay, a human body. If we have got energy, we can able to do a work. If you don't have energy, you won't be able to perform a work. Likewise, heat also regarded as a form of energy, because heat also does work. Now, what work the heat will do? Let us take an example of our natural source of light, sun. The sun gives us heat as well as light. And the light which has been given by the sun makes this universe, this environment, this universe visible. Okay, we can see so many things. Okay, a very tiny creatures to a big things we can see with the help of the light. As well, the heat which has been given by the sun also very useful. Okay, it makes to dry our clothes. When you wash your clothes and heat it in the sun, keep it in the sun. Okay, after few hours they dries up. So that means this drying of clothes is due to the heat given by the sun. And also the solar devices like solar heater, solar cooker, all these things. Okay, you can cook the food, you can boil water with the help of the heat given by the sun. And this heat is absorbed in that device, like the solar cooker and the solar heater, all that heat will be absorbed. Okay, and this heat will make the food or the water to boil or food to cook. So therefore, all these examples says, or we can consider that heat is a form of energy. And always the heat flows from a hotter body towards the colder body. And a hotter body means a body having a higher temperature. Colder body means a body having a lower temperature. Okay, and when there is a difference in the temperature, only in that case the heat will flow. If both the body will have got the same temperature, the flow of heat does not take place. So therefore, we can say that heat is a form of energy which flows from one body to another body due to difference in temperature. So let us consider two bodies. A stone, let us consider a stone. Okay, or a metal, anything you can take, two bodies. You heat one of the body and another body you don't heat. No need to heat. Okay, you will heat only one body, another body you are not heating. So the heated body, when you heat that body, automatically the temperature of that body it rises. And when the temperature rises, the body becomes hot. hotter. More the temperature it rises, more the body becomes hotter. Now, bring that two bodies in contact with each other. When they bring in contact with each other, what will happen? Now the heat will flow from a body having a higher temperature. That means the heat will flow from a hotter body towards the colder body. And this heat keeps on flowing between the two bodies unless and until both the bodies will attain the same temperature. When two bodies will attain the same temperature, then the flow of heat will be stopped. Okay? So, therefore, the other example I can give you, you take a hot tea, okay, and a spoon. You place a spoon inside a cup containing hot water or hot tea. That spoon gets heated up. Then the spoon will also become hot. Now what happens here is that the heat has been transferred from the hotter tea or a water towards the spoon, and the spoon will also get heated up. Then again, what to do? Now that spoon, which is not heated up, okay, which is not hot. Now that spoon you keep it and you place it in a tap water. What will observe? The spoon doesn't get heated up. Neither they become cold nor they become heat. Why? Because the temperature of the tap water as well as the spoon are same. That means if the two bodies are having a same temperature, that means if the two bodies are equally heated or equally they are cooled, okay, so in that case the heat will not transfer. There will be no transfer of heat. So therefore we can say that heat is transferred or heat can flow from hotter bodies between the two bodies, from the hotter bodies towards the colder body due to the difference in temperature. So therefore heat can be regarded as a form of energy. And the unit of heat. There are two units of heat. One is a CGS unit and other one is a SI unit. SI unit means the System International Unit of Heat is known as Joule. The SI unit of heat is Joule. And the CGS unit of heat is arc. Okay? And the relation between the Joule and arc. 1 Joule is equals to 10 to the power of 7 arc. 1 Joule is equals to 10 to the power of 7 arc. So these are the SI and the CGS unit of heat. Okay? But most commonly used unit of heat can be used as calorie or kilocalorie. Calorie and kilocalorie are the other unit of heat. Okay, and calorie. Okay, and calorie is the amount of heat required to raise the temperature of 1 gram of water to 1 degree Celsius. So calorie. How will you define calories? Calorie is the amount of heat, because another unit of heat is considered as calorie, and calorie is the amount of heat required to raise the temperature of 1 gram of water to 1 degree Celsius. That means take a 1 gram of water, okay, heat the water, 1 gram of water to a temperature of 1 degree Celsius, then we consider that as a calorie. Okay, so that is the definition of calorie. And other one is also the kilocalorie. Calorie and high unit can be used, kilocalorie. And there is a relation between the calorie and the joule. Okay, so that means 1 calorie equals to 4.2 joule. 1 calorie equals to 4.2 joule, or 1 kilocalorie equals to 4,200 joule. So how it is coming? Convert this calorie into kilocalorie. What to do? You just multiply it here with 1000. 4.2 into 1000. So what to do? Remove the decimal. 42 divided by 10 into 1000. 0 cancels here, equals to 4200 joules. Okay. So this way it has come here. So 1 calorie equals to 4.2 joule. 1 kilocalorie equals to 4,200 joules. So this is the relation between the calorie and joule. Relation between the joule and the arc. So these are the unit of heat, okay, in the CGS and in the SI unit. Now let us come to the next one, temperature. Now temperature is the degree of hotness and coldness of the body. It is the degree of hotness and coldness of a body, which means that Hotter body has got a higher temperature and colder body has got a lower temperature. And it only denotes about the degree of hotness and the cold. Temperature only denotes about the degree of hotness and the coldness of a body. So hotter body has got a higher temperature, colder body has got a lower temperature. Okay. So now we have the unit of temperature. The SI unit of temperature is considered as Kelvin. The SI unit of temperature is Kelvin, which is written as capital letter K, because it is kept in the name of a scientist. So therefore it is written as capital letter K. The other unit of temperature can also be used, that is degree Celsius and degree Fahrenheit. Degree Celsius, degree Fahrenheit are most commonly, especially the degree Celsius are most commonly used unit of temperature, and other unit can also be used, that is degree Fahrenheit. So we can measure the temperature in a degree Celsius or in a Fahrenheit, in a degree Fahrenheit, but the SI unit of temperature is Kelvin. And there is a relation between the Celsius scale and the Fahrenheit scale. So what is the relation? In C upon 5 equals to F minus 32 upon 9. So how this relation will come? Okay, how this relation has come is that in a Celsius scale, the lower fixed point, which we call it as the ice point, the lower fixed point in a Celsius scale is 0 degree. And in a Celsius scale, it has been divided into 100 equal parts. Okay, it is divided into 100 equal parts. Then in a Fahrenheit scale, the lower fixed point in the Fahrenheit scale is 32, and it has been divided into 180 equal parts. So therefore, 0, 0 cancels here, 2 5s are 10, 2 9s are 18. So finally what will come here? 0 doesn't have value, so you can write it here, C upon 5 equals to F minus 32 upon 9. So this is the relation of Celsius and the Fahrenheit scale. Okay, now let us come to the thermal expansion. Expansion of substance on heating is known as the thermal expansion. So expansion takes place in all the three different states of matter: solid, liquid and gas. And solid, they expand in a length, they expand in a volume, and they expand in area. Those substances which expand in a length, they are known as the linear expansion. Okay, they are known as the linear expansion. L-I-N-E-A-R, linear expansion. Okay, linear expansion means expansion in a length, known as linear expansion. Then other one is a cubical expansion. Cubical expansion. Then the expansion in a volume is known as the cubical expansion. Then other one is a superficial. S-U-P-E-R-F-I-C-I-A-L. Superficial expansion means the increasing area. So therefore, that means when the substance is heated, okay, they will expand in a three different states. They will expand in a length, they will expand in a volume, and they will expand in an area. So therefore, solid will expand in all the three different states. They will expand in a length, volume, and area. Whereas liquid, they will expand. Liquid and gas, they will expand only in volume because they don't have a definite shape and a definite size. Okay, so they have only definite volume. So therefore, their liquid will expand only in liquid and gas, they will expand only in volume. So which we call it as a cubical expansion. So these are the terms, so you should remember in a thermal expansion. So in the next class, we will come to the expansion in solid, liquid